The original proposal was to take 130 megagallons per day, producing 65, half of that, 65 megagallon per day of fresh water, and returning 65 megagallon per day of brine at double the seawater concentration, 70,000 part per million. So you start with seawater at 35,000 part per million, draw it in your intake at 130 megagallons per day, make half of it fresh, 65 megagallon per day, and send 65 megagallon per day out with twice as much salt. It's been on the books since 2002. There were a variety of economic and environmental controversies. Again, I mentioned the brine disposal was a problem, and then also the City of Huntington Beach and the Orange County Water District were waiting final approval by the California Coastal Commission, and the Coastal Commission was requiring a GHG mitigation plan, greenhouse gas mitigation plan. California's new law, AB 32, regulates carbon dioxide in excess of 25,000 metric tons a year. And again, the two biggest issues were brine discharge and CO2. The plan for the brine was to just discharge it into the ocean directly. And the TDS stands for total dissolved solids. So they were just going to put all of the total dissolved solids in the brine and put it right back into the ocean. We can get into how much of that if you take the discharge rate Q, 65 megagallon per day, and the density of that solution, and multiply it by the concentration of the salt in the solution, you come up with 17,655 metric tons a day. Of salt going back into the ocean at that discharge rate. And these are the numbers that support that calculation. The discharge 65 megagallon per day, the density about that of seawater, 1,025 kilogram a meter cubed, concentration twice the salinity, 70,000 part per million. 7%. Sodium chloride concentration in the ocean is about 85% of the total dissolved solids, but there's other salts. The difference is made up by other salts that are in the water. And the AES power plant, their plan for offsetting carbon was to just buy wetlands. In other words, they were going to do a program that carbon credits, buying credits, carbon offsets. Carbon offsetting, you buy carbon wetland projects or something like that in exchange for the right, if you will, to emit CO2 into the environment. So how much carbon dioxide is Poseidon indirectly emitting? We can take the 65 megagallon per day that they're planning to produce of fresh water, and we can look at the energy usage. Again, reverse osmosis from a chart I had of desalination energy rates. It takes 4 kilowatt hours of energy to produce a meter cubed of seawater by the reverse osmosis method, which is what is proposed for the Poseidon desalination plant. And you can then look at, you can estimate the various amount of carbon dioxide output, assuming natural gas. These are the U.S. Energy Agency releases the figures on what the average kilogram CO2 output is for a kilowatt hour of electricity produced from natural gas versus coal versus other methods. And take those rates, you can come up with the fact that there's 541 metric tons a day of liability, and that ends up being 198,000 per year. And remember, the regulation is 25,000 a year. So they're in excess just by the energy that they use to desal the water. The plant produces much more than that. The energy plant, the AES power plant itself, produces more energy, but the Poseidon desal station is only using a fraction of that. But still, even the fraction of energy that they use is equivalent to 541 metric tons a day, which equates to almost 200 a year, 200 tons a year, and the regulation is for 25 metric tons a year. So, like I said, the AES power plant produces much more. It actually produces 11,933 metric tons of CO2 a day. And the 541 that the Poseidon desalination takes is only 4.5% of the power plant. The power plant is a 904 megawatt plant, so that's producing 21 million kilowatt hour per day, and that's where I get the CO2 rate of 11,000 metric tons a day, almost 12,000.